Go to YouTube. Oh, yeah, it's recorded. So thanks, Joe, for joining us today for this webinar from the Water Loss Specialist Group, presenting on the impact of mains renewal and NRW reduction. I feel like I don't really need to introduce Jo, given her kind of extensive experience and really impressive CV. But I really think the best person to introduce Jo is actually Jo herself, for those who don't know her. But so I'll leave it to you, Jo, to really give your own introduction. But thank you for agreeing to do this webinar. Appreciate it. Over to you.
Oh my goodness. Well, hi everyone. Very quick introduction. I'm an independent consultant working in the field, particularly of buried assets and water mains. I have managed leakage activities, but I've also managed a lot of other activities related to water mains. And I tend to look at leakage as just one aspect of the overall asset management of the water network. And so this is looking at a particular aspect of that network. And it is based on, dare I say, 50 years in the industry, including 30 years working in various UK water companies. So it wouldn't be a water loss specialist group without this diagram. So I'm sure a lot of you have met this, although interesting enough, in the UK, we tend to use a different approach based on a similar analysis, but going by the acronym of PALM, which is prevent, awareness, leakage, location, and mend. And this is obviously all about prevention, but using the diagram, we'll be looking at this targeted mains renewal. Now, mains renewal is expensive, and because of that, to justify it purely on economic basis, you need to have quite a high burst rate to make it worthwhile. But some research has shown that as pipes deteriorate, even the repairs can in themselves cause more failures. And Dave Pearson, who I'm sure a lot of you know, did a presentation to Water Loss 2007 with the wonderful title of, "Do you know how many of your colleagues will come to your funeral?" Which was really looking at this issue of how repairs and the disruption and pressure waves caused by, for instance, shutting down the main, taking the excavating around the pipe, can actually cause more failures in themselves. And this can be shown graphically by a graph. There may be a little tip up at the beginning if problems with installation have occurred. So it's sometimes known as the bathtub curve, with a curve at the beginning. And the key is really getting that right point to replace pipes to make it most economical. So when you're looking at targeted mains renewal, how much do you need to replace? Is it just odd pipes? Is it a whole DMA? What's the best method? Here you've got some open cut going on, but is a trenchless method's better? And then when you're replacing, should you replace just the main, or should you replace services as well? Either communication pipes, or depending on the legal situation, you might replace right up to the property. And of course, the decision of what materials to use. And if you're deciding whether you just keep repairing or whether you are going to replace, then customer services needs to come into this. Do you have service standards? So for instance, in the UK, any interruption to supply more than 3 hours has to be reported to the regulator. And is it better to do one long major disruption or shorter interruptions, but more frequent? And then I've already mentioned the costs, and you need to think about short-term costs as well as long-term costs. And in fact, there was a working group that looked at this within the water loss specialist group, developed a guidance document. It was never published as an independent guidance document, but it is included in the book Water Management and Water Loss, produced by Stuart Hamilton and Ronnie Mackenzie in 2014 as chapter 4. Sadly, credit was not given to the repair or replace team, and a lot of people from the water loss specialist group did contribute to that initiative. I'd love to call out all their names now, but I'm afraid I won't have time. But I recognise all of you guys, and thank you so much for that contribution. I will just touch briefly on replacement methods, because I did just say, well, you can either do open cut or trenchless. And often people aren't aware of all the trenchless options that are available. So you've got the traditional open cut, horizontal directional drilling, often referred to as HDD, pipe bursting, which actually uses the existing pipe, but fractures that in a number of different ways so that you can replace size for size, and relining. So if I whip through those, open cut, I think a lot of people know that. It's tried and tested. You can use a whole variety of materials to replace the pipe. Generally these days, I think types of PE or PVC are used. It can get very expensive in metalled road, and you can see in the photo the road surface has been sawn, and it does reduce the life of the road, and there's been research to show that. It is very disruptive to road users, but you can install the pipe and then reconnect services one by one so that customers are not without water for a long time. I mentioned HDD. It's much less invasive. I know it looks a large machine, but actually the entry and exit pits are quite small. You can actually guide it, and you can see the diagram here, where you will have one person checking the route of the drilling head and guiding that where necessary. The problem is it can be very difficult to connect into that pipe. It does mean you've got to excavate down, and it's particularly used for instance, cutting under a railway, a major road, a river, or or something of that sort. Then we come to pipe bursting or splitting, different methods of opening up that pipe, and it can be quite disruptive to the surrounding ground, and careful surveys of utilities in the area needs to be carried out because of that. And if that's a problem, then using pipe bursting can also be a problem. And then finally, relining. This usually has at least some reduction in the diameter of the main, but that can be minimized. And these days there have been some developments in, for instance, spray-on lining, so that you have semi-structural or even structural spray-on lining with the minimal reduction in the pipe diameter. And often the improvement in the interior surface, reductions in roughness, that can offset any reduction in diameter. Here you can see, for instance, in the photograph in the bottom right, a roll down machine. So that's reducing the diameter of a PE through pressure, and then as it goes into the main, and you've got similar diagram here, it gradually expands back out. Now, this isn't a presentation about these methods. So if anyone does want to find out more information about these, I'd first of all refer you to the International Society for Trenchless Technology, which website, which has a very good description of each of these methods, and you can go in and have a look. Or if you look on the International Society first, it lists all the national societies. So for instance, there is a UK Society for Trenchless Technology. There's the North American Society for Trenchless Technology. The list is very long. I won't go through the whole thing, but do have a look. And although the members of the Trenchless Technology Societies are providers of this technology, they are provider agnostic. They will give general advice, and certainly in the UK organisation aim is to promote trenchless technology, not to promote any particular method. Now, whilst this is going on, you have got the issue of how you maintain supplies to customers, and rider mains are one option. Now, I think some people, when they hear about rider mains, they think, oh, it'll just be a little pipe in the corner of the sidewalk or pavement, which, you know, won't take up much space. Here you can see a hydrant with a unit supplying some lay flat hosing. So you can see it can be quite intrusive. It's a security issue. And here you may need to excavate down to the services to maintain, if you like, business as usual for customers. So when you're thinking about renovating mains, you do need to think about what's going to happen to the customers. But this presentation was about what's the impact on leakage if you renovate mains. Will leakage go back to zero, which I think some people do expect? Well, does it? There's been a lot of research in the UK, and I'm now going to go through that research. WRC initiated really the research way back early in the millennium. And that was very much in response to work that was carried out at the end of the last millennium and the beginning of this millennium to renovate mains in the UK, principally to improve water quality, because there were a lot of ferrous mains which had corroded internally and which were leading to discoloured water, and our drinking water regulator required this to be eliminated. But people wanted to know what benefits that would deliver on top of the water quality benefits. So I mentioned WRC, and they initiated a project which was then taken over by UK Water Industry Research, UCWIR, so that more UK water companies would participate. And this actually developed some methods of predicting leakage reduction, and also looked at the question of, well, what would it be with or without communication pipe renewals? And this is a graph which shows what that reduction would be, which is from a presentation that Dennis Dello gave way back in 2009, who was very well known in leakage circles in the UK. And the project showed some very interesting results. Yes, nightline and repair numbers did decrease after renovation, but in certain circumstances, there wasn't a significant overall leakage reduction. And in some cases, it could even be negative. Either if you had a relatively low leakage threshold already, and bear in mind, a lot of the renovation was done for water quality purposes. So it could be done in DMAs where there was a low leakage level. The other thing that would affect the impact on leakage was if only a small amount of leakage of pipes in the DMA were replaced. This varied. I mentioned initially it started with a smaller number of companies and then was enlarged. So the brackets are the smaller sample, and then the main number is with the larger sample. So it was interesting that did change. The good thing is that there was no evidence of increases in the nightline for 2 to 3 years after renovation, because this was carried out quite soon after the major renewal. Then there wasn't a long period which could be used. It did say you need to spend time verifying that the leakage is on the mains. There were incidents where there seemed to be high leakage in an area, but actually it was on the service pipes or the connection into the boundary stop valves, which is the layout we use in the UK. And it could increase customer side leakage. Now, for those countries where you have metered usage, you may feel that's not an issue. In the UK, only about it, we still don't have full metering. And so customer side leakage is counted in the overall leakage amount. So this could cause a problem. And scraping and spray relining could actually increase leakage. And whilst there was not research into why that was the case, it was felt that particularly the scraping, a rack borer, if anyone's seen it's working, it really does lay into the pipes. It shakes them around a lot. You then spray with a liner, which certainly at that time was non-structural, and so you could have problems occurring because of that process. These issues and some other asset management issues were summarized in report 7 of Managing Leakage 2011, which is a project which I worked on, again with David Pearson, his name does crop up a lot, Malcolm Farley and Stuart Trow. This report didn't carry out any new research, but was a summary of a lot of the earlier reports I mentioned and papers that were given in the UK and elsewhere. It looked at different ways of modelling failures to predict what the impact will be if mains are not renewed, and it gave some details of different forward planning software to optimize the combination of mains renewals. So that was just an overview. Then we come to a project which actually started not long after the managing leakage reports were written. It ran over quite a long period, mainly because there were some financial issues regarding the funding of research with UCWIR at that time. A lot of schemes were looked at, but these tended to be more the isolated renewals rather than, as had been done for the water quality improvement programs, work covering whole DMAs. And a lot of interesting results came out of that. Burst-driven mains renewal didn't have much impact on natural rate of rise or leak detection initially, but did continue. Leakage did reduce, particularly if they were large schemes. So this goes back to the percentage of work carried out in a DMA. Customer calls diminish, so that's something that needs to be taken into account when looking at costs. An Excel spreadsheet was developed to predict KPI changes, so that is available with that report. And if we have a look at the results, then you can see how these vary over the period of the project. So we have leakage with a reduction, but not a huge reduction. Bearing in mind these were for mains which had a high burst rate, so it didn't necessarily consider communication pipes. And interestingly enough, communication pipes often not much change or even a bit of an increase until several years after renewal, when perhaps everything had settled down and the disruption caused by the renewal, all the leaks related to that had been found. Not surprisingly, the renewed mains, yes, the repairs dropped dramatically. Leakage detection hours and all the other leakage measurements did show improvements. So there definitely are improvements if you pick mains that are failing a lot. But you do need to think about those pesky communication pipes. Quite recently, we've just finished a project, and I thought I'd just give this a mention. It was carried out as a PhD project funded jointly with Sheffield University, who have a very active centre which looks at all aspects with buried infrastructure. And this carried out a lot of tests on cast iron pipes and some interesting results which help. It may not necessarily tell you directly what pipes to replace, but it can help improve the modelling of deterioration. First of all, pipes do develop leaks before they burst, so that you have a small weep which gradually gets worse before it finally bursts. Now, a lot of us may feel that that happens, if you like, intuitively, but this actually proved it and showed how it was happening and developed models which actually could predict how this deterioration would take place with the Smith-Watson-Topper multi-axial fatigue criterion. Now, I bet you didn't know that. The other thing that was interesting was that where you have small cracks, if you take the pressure off the pipe, so for instance, when the pressure's lower, either due to pressure control or, for instance, high demand, then the leak will close up and diminish, which is another driver for maybe trying to carry out leakage in periods of low demand, which can be higher pressure. That report is has just been published and is available from the UPWare website. I will be giving the detail of the UPWare website to visit. I haven't done particular links for each of these reports, but you can search on the website. And then we come to the main report, which I had hoped to be able to give you all the results of because it's a really interesting project. Unfortunately, the publication has been delayed. It's a bit later than we thought, and so I can't give you the results, even though I do know them, because they do need to go to UPWare members first. But to tell you a bit about the project, it took samples of mains renewed for different reasons. So it might have been the quality renewals that I mentioned earlier on. It might be due to burst pipes and the customer service aspect, or it might be due to reduced leakage. And it assessed performance before and after renovation up until current day, and it compared with the estimated performance if that pipe had been left unrenovated. And it looked at different renewal methods, and actually, whilst not giving the detail in quantitatively, because there were some issues around the data, it does rank the different methods, and HDD comes out top, open cut, then relining, and finally pipe bursting. There are some issues, and it can lead to, in fact, increases in leakage. Having said that, the benefits with the first three methods, open cut, HDD, relining, do remain. But for pipe bursting, if there are any benefits, they can actually, you can see an increase in leakage quite soon after the renewal is carried out. So please do keep a lookout for that report. I'm really sorry I can't go into details. I did talk to Joe Butterfield about possibly delaying this, but there's a whole program of webinars planned. So we agreed, well, I'll talk about it. You know that the report will be coming out shortly, I would hope within the next month, and go to the website. You can sign on, you can register with the website and get mailings from them, in which case you should get emails about reports that are issued. So if I just conclude, mains renewal is very expensive, but you neglect it at your peril. I did have reason to look at one very large water utility in the UK and their asset management performance as part of a planning inquiry. I was working as an expert witness, and I do believe that in that case, the renewal of mains was left too long. They got to the state that Dave Pearson talked about, you know, nearly 20 years ago, where for every repair they did, they were actually causing more leaks. But they have since then done extensive Renewal, and that has made a big difference. And even their leakage is coming down in the UK. Trenchless replacement, yes, it's frequently more cost effective. It also has great carbon benefits for water utilities thinking about their carbon footprint, but you do need to think about whether the leakage reductions will last. And so please do have a look at the report when it comes out, because that may affect your decision about the method to use. And if you are worried about leakage, then if you're already at a low level of leakage, then if you replace mains, it may not be the universal panacea, particularly if you don't replace the service pipes, and at least replace the communication pipes up to the boundary of the property. Or if you just pick and choose within DMAs, you may not get much leakage improvement. Models are available which can estimate future savings. So for instance, I mentioned in some of those UCWIR reports, they do come with spreadsheets that can be used to estimate future savings. And one of the big things that came out from the most recent project is the need to collect data. And the thing is that you need to collect data at the time the work is being done. There were lots of projects where it hadn't been recorded on GIS whether communication pipes had been replaced. And if they had been replaced, what method was used for the ferrule connection, and what type of joints were used with that service pipe if joints were required. And generally, I would say that what we have found is often lacking, and this isn't just from this project, it's from other projects. For instance, in the UK, we have a national failures database that we're looking at reissuing and updating, and that lacks information about communication pipes. And yet you frequently have more leaks on communication pipes than on the mains themselves. So please do think about those points for anyone considering carrying out any mains renovations. And I will be happy to answer questions. I hope Joe Butterfield's been keeping an eye on things. And I'll stop sharing the screen so that I can have a look at what people have been saying.
Okay, yeah, thanks, Joe. So if anyone does have any questions, yeah, just put them in the chat, please. Craig's got a question here. I don't know if you can read this, Joe, but have the reports discussed today or the upcoming one given insight towards leakage strategies for maintaining leakage in new networks?
Yeah, well, no, because I wouldn't call this a new network. There has actually been some research carried out, and on that case, I was working as one of the researchers rather than project managing. A number of the projects I've talked about, I've been project managing them. But on the new mains project, I was working with WRC and Antire, who carry out, who provide pressure testing services, amongst other things. And we did look at leakage in new PE systems. There was also another UCWIR research project that I wasn't involved with that looked at leakage in PE systems. The most recent one, I'm afraid, is not available outside of UCWIR members, for which you need to work for a UK or Southern Ireland water utility, I'm afraid. But if anyone is interested, then I didn't put my email on there. Perhaps I can put my email on. I can talk to them about that, because there were some interesting results from that.
Yeah, thanks, Joe. There's a couple of questions coming in. I've just got one first. Selfishly, I'll ask mine. I think on maybe the second or third slide, you presented what looked like the bathtub curve,
Yeah,
which is, statistical failure rates with time.
yeah.
When we get to that wear out phase on the bathtub curve, we see that kind of accelerated failure rates in main. So I was wondering if you had any thoughts or kind of comments on how we can avoid getting to that accelerated failure point, because it seems like when we're in that useful life phase of the bathtub
Yeah.
curve, sort of ceiling failure rates that we're kind of happy with, then it accelerates. So how do we target those?
Well, modeling techniques for the deterioration of pipes are improving all the time. We do cover some of the modeling techniques in the reference I mentioned to Stuart and Ronnie's Managing Leakage book. So anyone interested can look at that. But they have developed further. That's now 10 years old. So they've developed further. And there is research on that. Maybe we need to update or recreate the repair or replace group within the water loss specialist group, because things have developed. The other big improvement is that in the past, it was difficult to carry out non-destructive testing of water mains, particularly the sort of smaller diameter water mains of an ordinary distribution network. Systems have improved, and for instance, in the UK, SES Water did carry out an acoustic survey of the whole of their network ferrous mains. That was 5 years ago, and they are planning to repeat it again. And so that can also give an idea of how mains are deteriorating, but you need to link, that will tell you the wall thickness, but then you need to link wall thickness to failure rates. The last company I worked for, we took a lot of samples and shot blasted them, tested them at failure, and from that developed our own models of deterioration. And I would recommend that where possible, utilities do that, for failed mains, collect the pieces and have a look at them. What's the wall thickness? At what point have they failed? And just get to know how your pipes are performing. And then you've got the Sheffield University PhD that's giving more insight. So there's lots of research which will allow companies to pick that best time. I mean, you'll never get it absolutely right, and you can guarantee you'll have a DMA programmed for renewal, and you'll get a huge burst in that DMA just before you're due to do the renewal. Or a trunk main, you can guarantee a trunk main will fail 6 months before you're due to implement the renewal. But that's life, isn't it?
Excellent. There's a couple of comments from Ken, which are probably a little bit more discussion points than they are actual questions. I feel like, I'm pretty sure you and Ken know each other fairly well. Maybe it's better to have a discussion offline about that with him, because sounds like he's done some work in the past on this already.
Yeah.
So maybe we leave that one for kind of discussion between yourselves. So
Well, I see this one from Carlos Silver about costs. We don't tend to talk about costs, although I do give a cost example in Managing Leakage, just to show the sort of level of bursts you'd need to make a mains renewal cost effective purely on a cost basis. But the trouble is costs change. So, you know, and you get different rates of inflation for different activities. So it isn't that everything goes up at the same rate. So no costs, very few costs are included in UCWI reports because it immediately renders them less accurate as they go along. Some interesting points from Ken. Some water companies do reassess what leakage they can get to, and they generally actually do that before they carry out the work so that they can justify it, and then they will look at whether they're achieving it. And I know that, you know, for instance, in the Victorian mains replacement that was done in Thames Water, they did estimate the leakage savings that were likely to come out in the different, you know, and set new targets in DMAs as a result of that.
You got a
But
great,
you're,
sorry, just you got a great question from Stuart Tro, which of
oh,
course will
yes,
be a good one. No, Stuart. Does the project distinguish leakage reduction by reducing the minimum achieved level of leakage in the DMA
yeah.
versus reducing the average level of leakage in the DMA? By reducing the level of leakage above them out. I assume that you did look at the minimum achieved level of leakage.
The earlier research, the 2018 report, looked at a much wider variety of leakage performance measurements, which included MAO. The more recent one is looks at the Nightline, I think. I'd have to check the class, but it has a smaller number of performance measures, but it's looking over a longer period of time. So, and I would say, Stuart, if you want to talk to me about this, feel free. Happy to chat some more.
Excellent. There's one a good one from Carlos there. Another one, Carlos. In Portugal, there is a big discussion on the payback on renewal mains, taking in consideration if it's worthy basis savings. So, I not to preempt that, but it's something I was thinking. So, I guess from what you're saying there, NRW or leakage-driven mains renewal alone, the business case doesn't seem to add up. It's going to be about it's going to be about failures, supply interruptions, potentially discoloration as well. I've understood that correct?
Yeah, that was very much the focus of that 2018 report that was saying, well, if you're justifying renewal projects, you need to look at all the different aspects of a network performance, including things like customer calls. And yes, it's recognized that you may not be able to reduce headcount in a customer call center with one mains renewal project, but you should take it into account. The other thing which I didn't really cover is that mains renewal will may well contribute to a leakage reduction program, which in itself may be part of a supply demand balance calculation. And so the whole economic balance of mains renewal changes if you're getting close to needing a new source. So if you're comparing the cost of developing a whole new resource versus mains renewal, then it may be mains renewal will be the solution, which is how Thames Water were able to justify their mains renewal program. So the other thing is that there may be external factors. So I would say in the UK, it's partly about managing water resources. It's also about public image, because if you're trying to get people to reduce their water consumption and you're reporting levels of leakage which however good they may be internationally, people perceive as higher than they should be, then that is another reason. And add to that regulation and government attitudes, there are all these less specific pressures that may push for more mains renewal.
With that business case then, Joe, do you think with the kind of, well, we've seen a lot of technology now around modeling tools and building these modeling tools using AI, machine learning, which kind of promotes more of a segment level renewal. So they look for one bit of pipe over here, one bit of pipe over here, renew those. Whereas a lot of UK utilities have promoted more of a cohort renewal for cost benefit kind of reasons. Do you think that business case changes with the onset, with the acceleration of these AI models and things?
Well, I would hope that an AI model would take into account some of the findings from these various research projects. And I can see Rafael Radecki has asked an interesting question, should you replace the whole DMA or focus on pipe deterioration model results only? And that issue is considered in these research projects that I've looked at. And there's no easy answer. You have to really look at every scheme and look at the variations. The good thing is that now, with the sort of speed of computing and AI and everything, it is becoming a lot easier to carry out optimization analyses to come up with best solutions for a mains renewal program year on year. But it's still quite a complicated issue, and particularly, if you've just got one or two mains that are always causing the problem, then yes, it may well be you just replace those and then manage the network from there. Similarly, if you've got a DMA which has high leakage, you can't get it down, you're pretty sure it's mains, they're constantly leaking, the leakage is on the mains, then yes, you may need to renew all the DMA. But in the middle, then it's much more difficult, the sort of 50% mark. Do you do the whole DMA? Don't you? Research has shown that if it's less than 60%, you may not get a reduction in leakage. So then you need to think about, well, what are the drivers? What are the costs? What are the priorities? Are there other areas that are more urgently needed? So I'm just trying to read Jörg's note. And thank you for asking a provocative question. I would expect no less of you.
Yeah, so it's around if we don't replace enough, will they sort of collapse at a point in time? I think that was a big driver for unpaid, right? So we've seen a huge increase in major renewal for unpaid.
I think for those of you who are not aware, there has just been an independent water commission who has looked at the water industry in the UK and come out with 88 recommendations, one of which was that investment in assets should take into account the condition of the asset itself, as opposed to just looking at outputs like customer service, interruptions to supply, which is what has been the driver for mains renewal up till now. And there has been a massive hike, 3 times the size of the mains renewal program for the coming 5 years of the past 20 years. So that's why I said that, yes, mains renewal is expensive, but you put it off at your peril. you could get into the situation that some water companies have got to, where, quite frankly, their mains are failing rapidly. They can't get leakage down any further. And these days, with climate change, and I don't know a country, well, maybe one or two that are not resource constrained, but, you know, abstracting and pumping water is expensive, even in countries where a lot of it's done with renewable energy. So we need to be thinking about that as well. And, you know, there are the carbon groups within the water loss specialist group. And, you know, this is another aspect of carbon. It's not, you know, maybe this would be considered type 3 carbon if we're looking at that, but you need to think about alternative carbon, or the carbon footprints of alternative policies. And I would hope that water utilities optimize the carbon footprint as well as the cost, because quite frankly, we can minimize the cost, but the way that the climate change is going, that may be the least of our worries. You know, we only have to think about the sort of fires and that sort of thing that are occurring in Southern Europe and other parts of the world. You know, it makes mains renewal pale into insignificance.
Yeah, good point. I think that sort of does lead into Samuel's questions around essentially, can we offset some of the costs using ALC? So cost of renewal offset using ALC. I guess from the point from this is, you know, if we are offsetting cost of ALC only for a certain amount of time, we can do that before they do deteriorate and go off the curve.
And well, I think Gerald Murphy has posted a very interesting comment, which just shows, you know, these days with GIS. Oh, and there was a question about asking about the UK National Failure Database. It's a matter of watch this space. There is a report due to be published. It's literally going through final checking with UCWIT at the moment, but it will be for water companies only in this, you know, and UK and Southern Ireland water utilities only. But it's very much the first step in updating and improving the failure database. I would totally recommend every country to collect as much data as they can, to pool it where they can, because the more data you can include in a model, the more it, you know, if you're using things like AI and machine learning, the more information it has, the more accurate it can be. If anyone is interested in learning more, then I would suggest you contact UCWIT. The HQ staff are very much looking at where they take the failure database as the next steps.
Yeah, potentially we can bring that in.
Yeah.
A global initiative would be quite fun on this one. Yeah, so Gerald's message there, you just mentions about sort of more localized repairs, which in some ways does that maybe contradicts the findings around whether you replace a whole DMA or not. Probably due to the material by the sounds of it, because it's HDPE and install standards.
Yeah, and there are different drivers. I think one of the biggest things, I mean, Gerald makes points about replacing, you know, different mains materials with different drivers, and he makes a point about poor surround materials, installation, which includes reinstallation. And I go back to the different methods and the impact on leakage of using different methods of renewal is important. But I do think that with greater computer power, it is much easier to come up with optimization systems. And there are specialist companies who can work with water utilities if you don't have the skills within. I won't publicize any particular one. There are plenty out there. And I'm sure if you come to Water Loss 2026 in Rio, there will be presentations about that.
Okay, great. We're coming up to the end. We've probably got time for just one more question from Rafal. Are these companies approaching renewal on a more holistic and system optimization view than just leakage and bursts?
That's a very interesting question, Raphael. I think it's horses for courses. In central London, Thames did completely redesign their DMAs and put in pressure management, and they were in some cases fed in different ways, connected in different ways, and so that was an opportunity. And I think generally, if there is a more widespread need to replace mains in the UK water companies will look at the overall design of the underlying DMA network and see if that needs renewing. Look at things like pressure control. It could be improved by interconnecting certain areas and that sort of thing. So it's certainly going on in the UK. And I think in other countries, I've done some work in New Zealand and there where they have the money to do it. And I would say funding there is quite tight. But if they can, they will look at DMAs and whether they can improve it.
Okay, brilliant. I think we should end it there. So thank you, Joe. That was great. This will be uploaded to the YouTube channel at some point. Hopefully we'll do it today, but we'll see. Yeah. Thank you, Joe, for your time.
Thank you, and thank you for great questions.
Great. Thanks, everyone. Bye-bye.
Bye all.